Long time since I've done a beat test. It'll be interesting to see how well this works. So fill def and configure things. The work I'm going to tell you about is some work we did under the DSbD TAP program. We were in 2 different cohorts. This is mostly work we did in the last cohort, working with the Sonata boards. And before I can... Oh, wrong way? Oh, there you go. So before I can tell you about the work we've done in there, I need to explain a little bit more about configured things and where we fit in. So we're a Bristol-based startup. We came out of Hewlett-Packard Labs to exploit some work that was being done there around how to configure large-scale distributed systems using declarative languages, and in particular in the spaces where there are lots of different stakeholders that want to drive the configuration. And we use that to create solutions that allow things to interact across trust boundaries, because one of the really useful things from that paradigm is if you're sending everything around declaratively, it becomes much easier to inspect than if you're trying to look at something that's more like an API that's purely transactional. Because of that, we're also part of the Cybersecurity, National Cybersecurity Center Accelerator, and we do quite a lot of our work with the NCSC and some other government agencies. These are the places that are typically typified by only employing people whose surname is a single letter. I don't know where they find all those people from, but so the patterns that they have at this space are often looking at trust boundaries. You can imagine they have networks that work at a certain classification that needs to be separated from other ones or from other partner agencies. And there are a whole bunch of patterns in that space around what it means to work across those boundaries. Our assertion from working in there is that that's great at a certain level and it carries a certain premium, but the actual patterns from there can be applied in a lot wider range of use cases. So we use the DSbD funding to create a demonstrator on top of CHERIoT IT that we've contributed back as a demo that shows how you can use those capabilities to exploit the same sort of pattern in a kind of more, a different sort of use case. Wrong way again. So the problem space we're working in is, most systems need to interact with each other. And they have to interact with things that they either don't trust or they probably shouldn't trust. And you can see this quite easily at the big organizational boundaries. But this applies also within an organization, and I think it also applies even within code. So, we're continually reusing components and libraries that come from other places. Supply chain attracts mean you probably don't want to trust the libraries that you're bringing into your system. So these kind of boundaries, I guess, systems have a lot more edges than you might think they do. And if you have the right tools to be able to think about those edges as trust domains, you can build things that turn out to be a lot more resilient. Clearly, providing security through air gaps isn't viable anymore. That's long gone. And actually what we're seeing is a move even at the organizational boundaries we work at, where the things that are moving across are no longer slow-moving document exchange. We're talking about real-time kind of data exchange. And those patterns exist, and they're actually published. The NCSC have some good papers around these things. What we wanted to do was to take that learning and apply it in a different space to hopefully start to create a bit more of an ecosystem outside of the niche space of working with government that will help us grow markets in that kind of area. So we wanted to take these patterns and say that the barriers really are partly to drive the thinking around what does it mean to be trusting code. I think we all reuse code, but you kind of bring in something, you tend to sort of implicitly trust it when probably you really shouldn't if you've got the right tools to be able to be more specific about what you want to do. And also about making it more cost effective. So, to give you one example from what I mean there, the work I was doing in CHERiot, at one point, I wanted to use a library. I knew it took a pointer. I didn't know whether it was going to actually hang on to the pointer or not. The documentation was kind of ambiguous. I started trying to look through the code. That just told me I'm not very good at reading other people's code. No great surprise. I'm not particularly good at reading my own sometimes. And then I realized, actually, I don't need to do that, right? I can put this in a compartment. Now I don't need to trust it. And not only that, I can be really explicit about the capability I give it. So I can say this is read-only, and you're not allowed to capture it. So I think there is tooling that comes now from these things that hopefully we can get out as the message to people that lets you reason more about what your trust relationship is, what your intent is in trusting code, even in code that you might be typically just building into your system. So that said, what we created, and this is available in CHERIoT demos, because we deal with configuration data all the time, we took the model that we would be typically using across these boundaries and implemented a configuration broker based around a whole set of compartments. Now, I have to say, I mean, the support from the CHERIoT community has been great in helping us get here and working out how to use the capabilities and things that are there. Most of that community are, compartment enthusiasts. I think I'm probably counted as something like a compartment fanatic now in terms of the amount of compartments we put in here, but it is very much there as a kind of exemplar of what can be done. Probably has a much lower ratio of lines of code per compartment than most other systems that you see that are doing these things. But the model we created basically has the network stack that's really compartmentalized. We got that from CHERIoT. Then we run the receiver from that runs in its own compartment. It does a set of crypto functions to deal with signed messages coming through MQTT because we don't want to trust the broker. That's an external thing, so we can do signing and encryption on the messages. But the crypto functions are coming in from another library reported, put those in a compartment. Anything goes wrong there, it's contained. The core of it, the configuration broker, is written and contributed to be reusable kind of as is. And the idea is you augment this with a number of parsers that use sealed capabilities to say, I'm able to parse this piece of data for you. The controllers, the things that receive data from configuration data, also use sealed capabilities to prove that they're actually able to receive that particular configuration value. And the client, the kind of provider, uses a different capability to say it's able to provide that value. So we have very strong compartmentalization around this stuff, which means that as we're bringing in configuration data and trying to turn it effectively from untrusted, supplied across the network into known good data that we want to pass on, all of the handling of that, all of the inspection of that is done in a set of parsers that are compartmentalized. Because one of the things that's quite interesting in those patterns that you see from NCSC, most people recognize you want to do something to trust the data at the boundary. I mean, we all write good validation functions for data that's coming in. What those patterns recognize is that actually even the act of looking at that data to verify it itself is part of your attack surface. And parsers particularly are things that are quite vulnerable to having data that can either corrupt them, cause them to explode, or potentially leave long-running problems. What's nice about this architecture with CHERIoT is I can run these things into a parser, and I can know by the time it's finished parsing successfully that I've got no extra state left. There's no heap allocation the parsers are allowed to do. It's not allowed to have any persistent impact. And if it goes wrong, all that goes wrong is it goes wrong in the parser. And then the things that are consuming the value don't even know that a new value's come in. They only get notified when I've got a known good new version of things that's come through. So as I say, this is up there. There's the link there to look at it. We've built this to be reusable. We think it's a good, hopefully both a good example of how you can use the capabilities, because I was coming into the CHERIoT program really grateful for the examples that were there that showed me how to use the different parts of the ecosystem. What we do, because we're more system people, I've been trying to kind of create a system level example of how you can pull some of these things together. And to put it into context, this kind of capability, because we've presented this to some people and they kind of have a bit of a so what, had this kind of approach been in place, then CrowdStrike would have been largely mitigated. CrowdStrike really came about luckily not from malicious data. Had it been a malicious attack, it would probably been even harder to recover from. But basically, data that was slightly wrong, that hit a bug in their parser, that caused the parser to do something, and the parser was running in a trusted domain with the Windows kernel where it really didn't need to be. Had this kind of pattern been used, and so we're drawing from patterns that are proved at the boundaries to an organizational level and trying to make sure that the same thinking can go forwards. Had this pattern been in place, then CrowdStrike, the worst would have happened was the parser would have failed. They wouldn't have got their configuration change out, but we also wouldn't have had however many hundreds of billions of dollars of outage and impact it was. So that's me. I've managed to beat the beep, which makes me feel really happy. As I say, we've done this. It's there. It's up there. If you have any questions on it, by all means, catch me or engage with us through the community.